In the diagram, the circle and the square have the same center and equal areas. The circle has a radius of 1 and intersects one side of the square at P and Q. What is the length of PQ? So, I guess to figure out the length of PQ, we have to look at this in the following way. First and foremost, we have to look at this statement that they have equal areas, the circle and the square. So if the radius of the circle is r, pi r squared is going to be equal to the area of the square, and I'll call the side of the square s. So s squared, like that. Now, they tell me that the radius is 1. So I can just substitute 1. And therefore, s will be root pi. Okay? So that's the first part of the question. Now what we have to do is figure out where exactly does P and Q cross. And what we're really doing, to be honest, is we're putting this on sort of a coordinate plane. And if you all remember, the formula for a circle is x minus, if the center, for example, was AB, like that, center of the circle. The equation of the circle is x minus a squared plus y minus b squared is equal to the radius squared. Now, the good news here is that radius, they tell me, is 1. So that's just 1 squared, which is just 1. And a and b we can also figure out. Notice we just figured out that the side length was root pi. So that means from here to here is root pi. And so is from there to there. And because of the symmetry of this diagram, the center will be half of that s value. So, for example, if you were to draw a line from there to there, and another line from top to bottom, like that, you'd be able to see that AB is really just equivalent to root pi over 2 and root pi over 2, like that. So that helps us out. So this equation becomes x minus root pi over 2 all squared plus y minus root pi over 2 all squared equals 1. Now to figure out P and Q, where they actually cross that x-axis, we are basically asking to find the y-intercept. So we set y to 0. So this becomes x minus root pi over 2 squared. And if y is 0, we can just square that, and that becomes pi over 4, like that, is equal to 1. So x minus root pi over 2 all squared is equal to 1 minus pi over 4. And if you take the square root, it would be plus or minus 1 minus pi over 4 under the square root sign. And then finally, isolating for x, it would be root pi over 2 plus or minus 1 minus pi over 4, all under the square root sign. So one of those is P and one of those is Q, right? Since there's two values. And to get the length PQ, we just have to subtract them. Like, for example, if this was 2 and this was 5, to get the length PQ, you just go 5 minus 3, which is 2. So it's the same kind of story. We have to subtract one from the other. So PQ will be the first one, pick the larger one, and the larger one of those is root pi over 2 plus 1 minus pi over 4 under the square root. And you subtract from that the smaller one of those roots, which would be pi over 2 minus. But if you're subtracting a minus, it becomes a plus. So like that. And then these guys cancel, this one and this one. So you're just left with 2, 1 minus pi over 4. And this is the answer. But the answer choices don't look like that, so we have to manipulate this a little bit. We add the fraction, and we get 4 minus pi over 4. And then if you take the square root, this becomes 4 minus pi 2, and then 2 on the bottom, and then the 2's cancel, so you're just left with 4 minus pi under the square root sign. And that would be answer choice A for number 20. In the diagram, the grid is made up of squares. What is the area of the shaded region? All right, we have to break this up into, little triangles and things like that. So this is the first one right here, that triangle, like that. And that's going to be 1/2 base times height, and the base 3 and the height is 1. Then I'm going to add this rectangle, and these are unit squares, right? Because from here to here is 2. So each of those is like 1 and 1. And this whole thing is 12, and there's 12 of those squares, so that means each of these is 1. So those 3 have an area of 1 each. So add 3. Okay, that takes care of that. Let's move on. Now let's go to this triangle right here. Again, 1/2 base times height. Base is 3, height is 1. And then let's add, let's see here. Well, there's several ways of doing this. I mean, it doesn't matter. I mean, whatever way you're comfortable with. I'm sure you have a shortcut. Here's 1, 1, 1, that's 3. And then again, this triangle, 1/2 base times height. And this little guy, 2 of those, so plus 2. And then finally, one small triangle, 1/2 base times height, with a base of 3 and a height of 1. All right, whatever way you feel comfortable, as long as you get the right answer. So this looks like 3 over 2 plus 3 plus 3 over 2 plus 3 plus 3 over 2 plus 2 plus 3 over 2. So this adds up to, let's say, 3, 3, and 2. That's 8. 3 over 2, 3. That looks like 6. So that's 14. So there you go. Number 18, the answer is 14, and that would be choice C. A rectangle with height x and width 2x has the same perimeter as an equilateral triangle with side x10. What is the area of the rectangle? Well, the perimeter of that rectangle is 2x plus x plus 2x plus x, which is 6x. And they're telling me that is the same as the perimeter of the equilateral triangle. Triangle has side labeled 10, and because it's equilateral, all sides are the same. So 10, 10, 10. So that perimeter is 10 plus 10 plus 10, which is 30. And they're saying that those two perimeters are equal. So this is equal to that. So 6x is equal to 30. And therefore x will be 5. So what do they want? The area of the rectangle. Okay, area of the rectangle is 2x times x, which is 2x squared. Substitute x equals 5, and you get 2 times 5 squared, which is 50. So number 13, the answer is B. Surface area of a cube is 54. The volume of that cube is. The surface area of a cube is written as 6 times the area of a face of the cube. Now the face of a cube is always going to be a square, right? A cube is basically made up of square faces. So the side, if it's x, the area of the face is just x squared. So 6x squared is the surface area of a cube, and they're told me that it's 54. So solving for this, 54 divided by 6 is 9, and therefore x squared is 9. That means x is 3. Now the volume of the cube is given by the formula x to the power of 3. And if x is 3, it would be 3 to the power of 3, and that, of course, is 27. So number 14, the answer is D. In the diagram, the smaller circles touch the larger circle and touch each other at the center of the larger circle. The radius of the larger circle is 6. What is the area of the shaded region? Area of the shaded region, AS, is going to be the big circle, pi r squared, minus 2 of the small circle, so pi small r squared. Now the big circle, they tell you in this question that the radius is 6, so I can immediately plug that in. But what about the small r? Well, if you draw a line from one end to another, that full line represents the diameter of the large circle, and that is going to be 6 times 6, right? Because the radius is 6, so that's 12. But from the middle point, which is right here, to there, that's 6. So that means that the diameter of the small circle is 6. So that means the radius of the small circle is 3. So 3 goes here. So this becomes 36 pi, and this is 9 times 2, 18 pi. So therefore this is going to be 18 pi for the area of the shaded region. So number 13, the answer is D. In the diagram, square PQRS has side length 2. Points M and N are the midpoints of SR and RQ respectively. What is cos of MPN? Well, on the Canadian exams, you're allowed to use a calculator. So let's use a calculator. Why not? Side length 2, if M is the midpoint, SM would be 1. So this angle in here I'll call theta. So using the tan of theta, it would be 1 over 2. Use your calculator and you will get theta equal to 26.565. Now because of the symmetry of this diagram, that's 2 and that's 1. Therefore this is theta also. So therefore this angle in here, we can just call it, well, it's MPN. Angle MPN is really 90 minus 2 theta. And since we know theta, we can calculate that. It will be 36.87. And then now you just take your calculator and calculate 36.87 cos, and when you do, you get 0.8. And that's 4 over 5. So 17, the answer is A. The entire exterior of a solid 6 by 6 by 3 rectangular prism is painted. Then the prism is cut into 1 by 1 by 1 cubes. How many of these cubes have no painted faces? Let's draw a cube, and I'm going to draw it fully to explain. So this is my 6 by 6 surface, and then on the other side I've got to draw 3 units. So this is sort of my cube. And then I'm going to cut this into 3s because that's 3. So may not be perfectly drawn to scale, but you guys get the idea. And then this side is 6 by 6. So it's going to be like this. And there we go. So now what I've got to do is I've got to visualize when all of this is painted, what is it going to look like? All right, so here is my cube. It's 6 by 6 by 3. Okay, so first of all, if you find the volume, it's obviously 6 times 6 times 3, and that is 108. Now, if I were to break that up into 1 by 1 by 1 cubes, there'd be 108 of those cubes, correct? Because each of those has a volume of 1. Now they're saying, when you paint this whole thing, how many will have no painted faces? Well, the ones that will have no painted faces are the ones that are inside, right? The ones that we can't see right now. So there's a few ways of doing this. You can either talk about it from the inside or talk about it from the outside, whichever way you feel is easier. I don't know, it's up to you. I think talking about it from the outside is a little bit more visual, so that's what I'll do. Of these 108 faces, there's some that are inside, and therefore they will not be painted. So what I'm going to do is just going to count the ones on the outside, and then I'll subtract that from 108. Well, obviously the ones that are staring at me, so all these guys are going to be painted. I'm just looking at that slab. Well, how many are there? Well, it's 6 by 6. So immediately, that's 6 by 6. I know those 36 cubes are going to be painted. And then by the same kind of thinking, the other slab back here is also going to be painted. And that's the exact same. It's another 6x6 slab, so another 36 will be painted. And then it gets a little bit trickier. These guys, this sort of, whatever you want to call it, a column, all these guys, that's going to be painted. How many are there? Well, 1, 2, 3, 4, 5, 6. So 6 of those. And then similarly on that side, all those guys that I can't see, it's going to be identical. Another 6 of those. Right? So far so good. Hope that makes sense. But then I've got these 4. 1, 2, 3, 4. And then I will have 4 on the bottom, exactly like that. So 4 and 4. So these are the ones that are painted. So what is that? 72 plus 20, right? So that's 92. So 92 will be painted. Okay, well if 92 are painted, and there's 108 that are total, the ones that are not painted are 108 minus 92, and that is 16. So number 18, the answer is 16, and that is choice A. A solid wooden rectangular prism measures 3 by 5 by 12. The prism is cut in half by a vertical cut through 4 vertices as shown. This cut creates 2 congruent triangular-based prisms. When these prisms are pulled apart, what is the surface area of one of these triangular-based prisms? Well, let's label this. It's already labeled. I'll just continue to label it the way they've done it. 12. This is 5. I think that should be good enough. The first thing I want to do is calculate that diagonal. And that can be easily done using Pythagoras. And that's going to be 13. And some of you already know a 5, 12, 13 triangle is a right triangle. All right, I think I'm ready to figure out the surface area. So the first one will be the top, the bottom and the top, and those are exactly the same. So it's 2 times 1/2 base times height, where the base is 12 and the height is 5. And then we will calculate that side, which is a rectangle. So that's just a 3 by 12 rectangle. And then this side here, which is another rectangle, it's a 5 by 3 rectangle. And then the last part is this shaded side, and that is what? It's a 3 by 13 rectangle. All right, so 12 times 5 is 60 plus 36 plus 15 plus 39. When you add up those numbers, you get 150. Number 17, the answer is D. PQRS is a square with side length 60 and center C. Point W lies on PS, so that WS is 53. Point X lies on SR, so that XR is 40. The midpoint of QR is W. Point Z lies on PQ. What is the length of ZQ so that the total area of the shaded regions is equal to the total area of the non-shaded regions? Well, let's split this up into a couple of regions here. I'll do that line, and I think drawing that line would be sufficient. And here we go. So ZQ I'll just call X. Now they're telling me that the shaded area is equal to the unshaded area, so that means the shaded area must have a volume half that of the square. So the square is 60 times 60, so half of that. And that is, what is that? 1800? Yeah. All right, so now let's figure out the formulas. We're going to need some dimensions here. This they give me is 53, this is 40, so this is 20. And then C is the center, and that's very important because that's going to help us a lot. Since C is the center, we can essentially just split it down the middle and we'll get 60 divided by 2 for those half sides, I guess. So that means from here to here is 30, from here to here is 30, from here to here is 30, and so on. So let's see what we can do here. 1800. Well, if I use this triangle first, 1/2 base times height, 1/2 x times 30. Let's see, what can I do next? I'll just do this one. That's going to be 1/2 base is 30, and the height is also 30. And then this triangle right here, 1/2 base, which is 20, times the height, which is 30, and then 1/2 this triangle, 53 times 30. So that means 1800 is equal to 15x plus 450 there, plus 300, and then plus 53 times 30 divided by 2, 795. All right, so now put everything on one side. You get 255 is equal to 15x, and therefore x is equal to 17. So number 20, the answer is E. In the diagram, the area of rectangle PQRS is 24. If TQ equals TR, the area of quadrilateral PTRS is. All right, let's move this down just a little bit. So they tell you that the area of the full rectangle is 24, right? So let's just label this. I'll just call this side Y. And they've already told you that this is equal, these two. They've even put little symbols there to let you know that. So I'll call each of those X. All right? So length times width, therefore, would be Y times 2X. And that is how you calculate the area of a rectangle, and that's 24. So therefore, XY is 12. Now they want you to figure out the area of the quadrilateral PTRS, so PTRS, like that. Well, you can figure that out as follows. PTRS would basically be the rectangle, the entire rectangle, PQRS, minus this triangle right there, which would be PQT. Yeah, PQT. Well, PQRS, they already told you in the question, is 24. And then PQT, 1/2 base times height. Base is X, height is Y. So 24 minus 1/2. XY we just established was 12. So times 12. And therefore, this becomes 24 minus 6, which is 18. So number 15, the answer is A.